All right, let's do the isochoric process, and that's XD, this guy right here. Okay. What is the temperature at point D? So remember, this is 100 kelvins. Notice that we have gone from 8 times 10 to the 5th to 2 times 10 to the 5th. That means we've decreased the pressure by a factor of 4. Doesn't that mean that the temperature has been reduced by a factor of 4? So it goes from 100 to 25, right? What was that? What did I just do there? I think it's PV over T equals PV over T, right? And then the volume is the same. So it's just P over T is P over T. So 8 E5 over 100 is equal to 2 E5 over 25. Is that right? I think that's true. I think that's true. Basically, you just multiply both things by 4, and they're the same. Okay, so that's the temperature, right? Just look at the chart, and oftentimes you can just do it in your head. Okay, and then for the isochoric, and that's this thing. Isochoric just means constant volume, right? Let's find Q, U, and W, right? Now remember, Q is delta U plus W, right? Okay, so we're going to find these guys and add them to find Q, okay? So let's find the work first. That's easy, right? The work is 0, right? Because it's P delta V, and delta V is 0, right? Okay, so there's definitely no work done. Let's find the change in internal energy, right? Now, the way we're supposed to do it is we're supposed to use this formula. U is 3/2 nRT, so therefore our change in U is that times the change in temperature, right? So let's figure that out. Let's see, U is going to be 3/2 times 1.9254. That's the number of moles, right? We figured that out in the previous problem from the temperature and the pressure and the volume. All right, and then R is 8.31. And then our change in temperature is 75, right? So let's go 3 divided by 2 times the number of moles. I got to find it here. I'm going up arrow. There it is. All right, times 8.31 times, and it changed by 75. It's actually negative 75, right? And I get that it's negative 1800, right? So on the bottom here, this should be negative, right? And then that should also be negative if I can get a minus sign. Okay, so negative 1800 joules. The temperature, or the internal energy drops by 1800 joules. Okay, now let me show you the other way to do it. And write this down. This is what you do, right? The change in internal energy is just 3/2 times the change in pressure times the volume. Okay, so much easier than doing all of this, like figuring out what the moles are and then blah, 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 right? Notice it comes out to some round number, so it's got to be something simple, right? Okay, so it's 3/2. Our pressure is, our change in pressure is 1, 2, 3, 4, 5, 6. So it goes down 6. Down 6 times 10 to the 5th. Remember, that's times 10 to the 5th, right? And then our volume is 2E minus 3. So try that. So 3 divided by 2 times negative 6E5 times 2E minus 3. And indeed, that's negative 1800, right? Okay. So now we've got, what do we have? We've got, we got to figure this out, right? Okay, so Q is delta U plus work, right? The work is 0. Our delta U is negative 1800. So therefore, 1800 joules must have flown out, must have, it must have gone out of that gas. All right, so our Q is negative 1800, right? So this is pretty basic, right? The internal energy drops by 1800 joules. It doesn't do any work, so therefore 1800 joules flowed out, yeah? Go team, okay?